Hello class, how you doing? Welcome to the first session of our course for cryptography for CS 355. So this is going to be the week one's lecture material. Cool. So in this one, we're just going to have a high level overview of some conceptual course concepts, and we're going to talk about different things that cryptography lives in and how it applies to the world of computer science. There may be some terms that you haven't heard before, and that's perfectly fine. Don't get scared too soon. I'm going to be dropping a lot of information in here, but this is going to just be some tad bits of what we're going to be talking about in the future. So don't worry and don't think that you have to know everything all at once. We're going to get through this together. And by the end of this course, all these terms that you have here are going to be like second nature to you. So no worries. Let me get this resume. Okay, perfect. So some objectives here is we're going to learn and understand the basics of cryptography. We're going to explore some protocols and their uses within cryptography, and we're going to dive deep into some concepts such as private outsourcing, but also some pretty cool concepts and some real world examples that I have for this course. So first and foremost, what is cryptography? And what cryptography is, and I'll give you the both textbook definition and some examples of it. So the definition of it is the practice of the secure communication in presence of third parties, also known as adverses. It includes some mathematical algorithms that we won't go too deep into this course with, but we'll touch upon a little bit. And we'll talk about some protocols and confidentiality, some integrity, authentication, and some information. So, what is an example of this? So, the example I have here is that have you ever written a secret message to one of your friends, but you didn't want anyone else to read what they're saying? So, you might be using some sort of code. You may have heard of like Morse code that they used during the wartime, or some special other way that you've written it that only you and your friend may know. This is an example of cryptography. So, what we're going to talk about next is asymmetric encryptions. So, one of the most fundamental things that you'll see, and you'll see this example all over cryptography if you haven't seen it yet, you'll hear about the story of Alice and Bob. And what I'm going to do is just kind of show you an overview of it, and I'm going to walk you through it on the next slide. So, first, we look at step one, right? So, we have Alice uses Bob's public key to communicate with her with a message. But she wants to send that message and she wants to have it encrypted. And next, that message gets encrypted using Bob's public key. And then to get to Bob, Bob uses his own private key to decrypt it, to understand that message. I'm going to walk you through how that works next. So let's say this, right? We're doing the building blocks of this. So you have a message and you want to send it. So what you do, you want to send it to Alice, but what you have to do is you have to get encrypted. The way it gets encrypted is by using K, which is considered a key. So that key is being used to encrypt. Next, what we'll do is actually send that message over by using this formula here is E, and then we have K, M equals C. So E is for encryption, K is for the key, M is for the message, and C is what we're going to call the cipher. When it gets done, it gets ciphered over, it gets transmitted, and then boom, it gets sent over to the next person. Who we're sending it to now is Bob. But Bob doesn't really get it automatically. What it goes through is another process called decryption, what we'll talk about right now. So what happens is that they get the cipher. The cipher gets to Bob, but he doesn't understand it. So what happens is it gets decrypted by using another key. As we know, this is a private key for him to understand it. What happens is that it gets decrypted using this formula here: D K C equals M. So D is for decryption, and then K and K K K is for the key, and then C is for cipher, and M is for message. So I'll have that breaking down right here. So here are the terms again. Um, the message is using. I just want to make a quick distinction here that the message is using a public key for encryption and then using a private key for decryption. So remember that public for encryption, private for decryption. So here are some terms. As I said, E is for encryption algorithm, D is for decryption algorithm. So we have to understand that E and D are ciphers in this sense. M is the message, or sometimes you'll have it referred to as the plain text. C is the ciphertext or cipher, and K is the secret key in this sense. So always remember that the encryption algorithm is always publicly known. As I mentioned before, this is one of the more fundamental things that you'll hear over and over again. You'll hear me say it all over the course, that the encryption algorithm is always publicly known. So next, we're just going to continue talking about the building blocks, and there's some concepts that I mentioned a little bit earlier. So here's more of a equation form, and then we can see that the encryption algorithm, um, for simplicity, is a message that gets encrypted using a private key, so a secret key. Sorry, it's using a public key using a secret key, K, and then it gets ciphered. It becomes a ciphertext. So M, then it goes using the E to get encrypted using K, and then it becomes EKM equals C. So you're encrypting it using a key. You're encrypting the message using a key, and it becomes the ciphertext. And then the reverse of that becomes a decryption. You have the ciphertext; it gets decrypted using a key. In this case, it is a private key, and then the algorithm looks like it gets decrypted. You decrypt the cipher key. You decrypt the ciphertext using the key, and it becomes a message. So just think of it as a little line graph. So the next thing that we're going to be talking about some use cases. So we're going to talk about the single use key. So this key is kind of used only one time. You see a special key used during emails as well. So it's not used, you can't use it multiple times. This is just a one time thing. As I mentioned, is more so common in emails. And then there's something called the multiple use key, used many times. And this actually refers to, you can use an example as files that are decrypted. You can use the same key from multiple different files. Okay, next. Let's keep in mind some things about cryptography. So cryptography is a great tool, and it helps us with the basic understanding of security with mechanism. But what it is not, it's not the best thing in the world. It has a lot of problems in it of itself. You have to understand that the tool is reliable, but it can be broken. And then I'll actually talk about some ways that we can actually break some cryptography rules. Um, but you should also try to invest in yourself and understanding how they work when it comes to security. Cool. So let's go on to then what else can you do with cryptography? So there's some cool stuff here that I'm going to mention, and this is what I mentioned earlier, some examples. So there's something called a digital signature. What a digital signature is, by textbook definition, is a mathematical technique used to encrypt authentication to ensure that the authentication and integrity of digital document, messages, or softwares. Those are some examples. Those are the textbook definition. And some examples is that in the real world, you will use a signature to sign a document, like you will maybe in class or you go into the office and you'll sign something, but you can't usually do the same thing digitally. You have to actually use a digital signature. What happens as well is that in the real world, you can actually use your same signature over and over again, but it's a little bit different in the digital world. So as I said here, so it says, however, that it does not work like that in the digital world, since it is very easy to catch somebody's signature and sign a whole bunch of things online. If that was the case, that you're using one type of signature, um, so we try to some tool that we use is actually digital signature that will have encryptions into it. So what how that works is a digital signature is via function of the concept of the content being signed. So sometimes you'll have some documents that are only specific. You'll have encryption only specific to that type of document. So if it were to get hacked, that type of signature cannot be replicated in a different area. So it becomes harder to detect and it's harder for hackers. But I'll show you some more cool examples that may surprise you that we can do in the digital world. So anonymous communication. This is actually a really big one, and over the last couple of years, there has been a lot of news revolving around, um, this autonomy and anonymity that we'll discuss here. So some of it. So let's go over the textbook definition. So anonymous communication is basically what it sounds like. Is where the identity of the communicator is hidden and anonymous, both intentionally or unintentionally. So I'll give you some examples. So in person, you usually, if you were to be anonymous, right, you can think of yourself wearing a mask, wearing a ski mask, so nobody knows who you are. They'll be able to keep your identity safe. If you guys remember, I want to say a couple of years ago, somebody won the Mega Million, and they wore one of the screen masks to kind of say stick anonymous. Um, I should have added it here, but it was a pretty funny thing. and that's kind of like a anonymous communication in itself over there. But in the digital world, anonymous communication is when you can send information over to somebody and then information or messages without revealing your name or some personal information. And we'll talk about next is what kind of examples are those. You'll see this very predominantly used within whistleblowers who want to share some information without putting themselves in danger. An example I think I mentioned over here that you'll see later on is Edward Snowden, and then the whole NSA case about the that he released. I think they called it the Snowden revelations, but he used a torrent that I'll talk about in a bit to actually leak that information out to the public, or I think it was private reporters. So an example of a anonymous communication. So it kind of falls into what I was just talking about earlier. So imagine that you're a journalist and you're trying to uncover a story about a corrupt company, a corrupt government agency, actually. So you might want to speak with somebody in the inside, but everybody's kind of scared. They don't want to talk about. They don't want to kind of release that information because they're kind of scared that their employer is going to retaliate, either firing, suing, or other punishments. So what can happen is that to have this communication happen is that they use something called a Tor, which is the onion router, which is a very secure router that's a private communication. That is a network with a security of that has anonymous communication and can be an option for whistleblowers to actually communicate with this reporter in this situation. You may hear about this in the news in the most recent time that a lot of whistleblowers start to use Tor actually as like one of their I want to say actually their main source of communication, but I could be wrong. Um, Next, we'll go over to the anonymous digital cash. So what this basically means in textbook definition is that a form of electronic money that can be used to buy things without revealing your identity. Uh, the problem here that you'll all talk about here is that how do you know um, about digital money, right? How digital money is kind of like a number on the screen. It's a little bit different than paper money because paper money you can actually see your value and you can see how much money you have. Digital cash and digital money is actually a very interesting concept, new age concept actually, since everything is just online. And I'll explain some ways that we kind of go around this idea of preventing double spending. So, ensuring that a digital coin is used once, identity is not revealed. Although, if somebody makes a copy and tries to double spend, the identity then gets revealed as a punishment, and then they can get into legal actions. And I think I have an example here. One of the most famous ideas of digital money is this idea of Bitcoin. I'm pretty sure everybody has heard about Bitcoin, about now, and all the altcoins and litecoins that have came from it. But in its conception, Bitcoin is a digital currency that allows anonymous transactions without the need of a central authority or a bank. This technology is actually used using blockchains, which I'll talk about later on in the course. But Bitcoin transactions are recorded in a public ledger called blockchains, but their users can maintain their anonymity by using different names, pseudonames, and instead of their real names. One of the bigger things that you'll see about Bitcoin and kind of this blockchain is that there's no central thing that it all lives on. Blockchain kind of lives on multiple different computers throughout its users, so it's never really one source that you can find all this information. So it makes it a little bit harder even for hackers to hack, since there's not a central place like a server in an organization where you can just kind of hack it and get all the organization's information. So it's a little bit different in that sense. Next, we're going to talk about protocols. So the definition of this is a set of rules and procedures that governs the way the computer communicates with each other. Protocols are defined as the formats and structure of messages and exchanges between computers. So one of the more famous things is the HTTPS that we always see, and we always see it on secure websites. We'll always see this in the beginning. So if you ever do www dot any URL, you will always see this HTTPS in the beginning. You may also see it sometimes without the S, without the secure. Um, so this is actually one of the bigger things here. So I'll give an example of how this actually works within the realm of the internet. So a user types in the URL into the web browser and it hits enter. So you go www.google.com, click enter. The browser then sends a request to the web server for the actually to receive that web information. So what happens is that the web server receives this request and sends it back a request in which it authenticates and allows that user to get that information. Um, so then you'll get stuff like caching and cookies. And that is one of the cool ways that it kind of receives information and then sends it back. And then here, as the web browser receives and responds, the render page comes on the screen for the user. Right now, it happens in the milliseconds. You're just typing in www.google.com and boom, it comes up. So there's a lot of things that happen in the back end, but that's kind of how it works when you're actually trying to get information from a web page. Cool. So next, we're going to talk about crypto magic. I call it crypto magic, but as you can also, um, I always think of the NBA player. Magic Johnson when I think of crypto magic. And then the reason why it's called crypto magic is because it actually does some phenomenal things that may seem like magic. So something that we'll talk about is the private outsourcing computing. Um, what the definition of this is as a way of computer performing tasks for you without revealing data or the algorithm that it did, the algorithm that you are using to do it. So an example here, we'll call it a helpful friend. So imagine you have a big math problem to solve, but it's too hard for you to do on your own. So you ask a friend to actually help you solve this problem, but you don't want to tell them what the problem is necessarily since it's a secret. So instead, what you do is actually you give your friend the rules to follow, like add this number together and then multiply by this number, but don't tell me what that answer is. And then what happens is that your friend actually performs this task. It computes it and gives you the answer without actually ever revealing what the original problem was. I know it sounds a little bit crazy here, but I'll actually give you some more examples of this. So an example of a private outsourcing computing, and we will use this in the world of computer science in this example. So a company might want to analyze a huge amount of data that they're getting from a customer to improve their marketing strategies, but you don't want to reveal the data that you actually have on the clients to this computer. Or you don't want to reveal it to a third party. So instead, what you do is that you actually do something called a private outsourcing protocols that allows them to send the computer that allows to send the uh, computation to a remote computer, which performs that analyzes the data without ever actually really seeing the original data. The company results of the computing are then sent back to the company, and then without ever revealing any sensitive information. And I know it still sounds a little bit confusing, but I think I have a better one here that kind of gives you more of what happens. So all of this is basically what a machine learning boils down to. So machine learning is an algorithm that requires large amount of data to learn from. So once you give it some information, it can be either sensitive or it can be public information. And what it does is that the company actually then uses this information in machine learning, and the machine learning understands certain logic, and then it will start to compute the data without ever actually knowing what the original data was, just by a simple set of rules. Um, and it's a pretty cool concept. It's something that is still being learned right now in the world of machine learning. Um, I won't go too much into it now, but this idea of supervised and unsupervised learning is one of the cooler concepts that you'll hear about. Um, May not be for me, but in the future. But machine learning is one of those things that you can consider when you think of privately outsourcing computing. You can think of machine learning as a way to help you. Cool. So next, we're going to talk about zero knowledge or the proof of knowledge. So the definition of this is a way to prove that you know something without actually revealing that you know it. So it's pretty cool here. We'll use an example, and we'll stick to the computer science realm of an example. Let's say that you want to provide a website or you want to enter a website that needs to know if you're 18 or older, but you don't want to reveal your exact birthday. You don't want to say I was born, January 1st, 1990, whichever. Um, so the website could ask you a specific type of questions that can actually get to the level of understanding if you're over 18. So sometimes we'll see is that the website could ask you to perform a calculation to using your birthday and then a random number, and then that actually reveals the results to them. If the results matches and then what they expected, then you are actually able to enter into the site. If not, then you'll actually get rejected. But the cool thing is that you will never ever have to actually reveal what date you were born, because the computing happens in the back to actually authenticate this request for you. I think I have another example. Oh no. So we'll actually jump into some practice quiz problems, and these are very important to do. I'll run through them as well, but think about them as well as I'm discussing this. So, what's the main purpose of cryptography? Is it to ensure the availability of information, ensure the effectiveness of data transmission, protect the protect the confidentiality, integrity, or authentication of information? Kind of sounds a little familiar. Or facilitate secure communication with a third party. Um, if you think about it, let's see if this actually works now. If you think about it, ensuring the availability of data doesn't really sound right here, so we'll cross this off. Ensuring that the data effective, enabling effective data transmission, a little bit, but I wouldn't say that's exactly what it does. Protecting the confidentiality, integrity, and the authentication or authority, the authentication of information kind of sounds like it. I think that sounds like a little bit more of it. But let's see the next one too. Facilitating secure communication with a third party. Maybe that sounds like something else that we learned, but I don't think this is it. So the actual correct answer is C. Cool. Bear with me. I'm trying to learn how these little pens work. Okay, cool. So next, let's go to the next one. Okay, so practice quiz question 2. What is the purpose of using Torn? And if you remember what is Torn, right? So what is the purpose of using a Torn network for anonymous communication? So let's go through this. Let's try this again together. So to encrypt messages being sent over the network. Um, Maybe that sounds like a feasible thing, but that's not the exact thing. Ooh, that's not the exact thing of what it does. So let me X this out here. To ensure the message being sent from somebody trying to spy on it, to to hide the message being sent from somebody trying to spy on on communication. Kind of sounds like it. Let's give it a check mark here. To prevent messages from being delivered to the intended recipient. Not sure. I think people use Tor to actually communicate, so I don't know why it would actually prevent them from communicating. So I don't think this is it either. And then to reveal the identity of a sender. Well, if this was the case, then there's no point of using Torn. You could just use iMessage and just message somebody. So this isn't it either. So by process of elimination, the answer is B. Okay, cool. Let's go on to the next one. I have a third. I think this is the third and last one here, or I might have another one. Practice quiz question 3. So, what's the purpose of using digital cash in in the context of cryptography? So, we actually can see that it is to either prevent double spending of electric money. Kind of sounds like it, but I'm not too sure. So, let's give it an X here. Not just the double spending. To ensure that all transactions are anonymous and secure. Kind of sounds like it. Let's give it a check mark here. To provide a secure way of storing sensitive information. Not really with the money sense. It does do that, but it's not that main purpose of it. So we're gonna exit out here. To encrypt communication between two parties. So we're actually encrypting information. That's not the reason why we actually use digital cash. So we're gonna actually X that out. And by the process of elimination, the correct answer is B. I feel like all the correct answers are B. I might be wrong. So let's clear this out.